Hello and welcome, people of the internet. What a great day to be alive. Um, this is day 13. Um, if you've been following me on this journey, you will know I did not post anything yesterday because I looked at the problem and I gave up. There's no point in even. I think I spent 15 minutes. I realized I was going down the completely wrong path by reading the question wrong. Um, so I gave up. I thought that was going to be the end of Advent of Code challenge, but here we are for day 13. And the question is basically you're given this input, you press the buttons this many times to get this answer. So if you press button A, you will move 94 times in the X direction and you'll move 34 times in the Y direction. Button B, same thing, you'll move 22 times in the X direction and whatever times in the Y direction, right? And the prize is at these positions. So all we have to find is the minimum number of tokens that we need to use to get to those points. For the tokens, it says how many. So every time you press A, it'll cost you 3 tokens, and every time you press B, it'll cost you 1 token, right? So I look at this, like straight away looking at this, my mind is going into math mode, right? Math equations. I remember GCSEs, like actually show you this. So I was just scribbling out, you can't see the actual equations, but I was just writing down if these can be solved through equations, right? But GCSE simultaneous equations coming in clutch, right? Even look at this, right? If I still have it, I'm looking at how to solve simultaneous equations right here. Um, I knew how to solve them actually, but once I think about it, once like thinking about it, I could actually translate the this method that we did in GCSE year 10, I never thought I'll ever use the maths from those days, but I tried to translate it, but then yeah, I realized there will be so many errors, especially with like the floating point numbers. That kind of method like never actually works out in code while you're like programming, because you'll have like 4.999 and that just passes down, right? Then I thought about it some more, you know it's just a question. um, and then I realized we did some linear algebra in the first year of university. Same things, simultaneous equations, but you solve it through a matrix now. Wow. um, so again I went back to the this well, I say this because I could not remember a single thing I did from university, but I knew it was a possibility. So I searched up matrix linear algebra equation solver, and then I put this equation, so these, um, what's it called, so let's say if we have a and b, so all I said was 94x, so 94 times by something, plus 22x times by something will give us 8400. And then x2, let's call it, so 34, or we can call it y, we can say 34 times y plus 67 times y will give us this. That's the equation, like the first equation that I created, right? Yeah, I converted that to a matrix, and then I put it in our little matrix solver that I use so much in uni, to solve all my problem sheets. As you can see here as well, I don't know if they're the same number, or this was for the second one that I was trying to see what the error will be. This one doesn't work as the example says, but anyway, it gives you a number, right? In here, I remember some of this, Gaussian elimination, that really did my head in when I was learning it in uni. But just looking through, I looked at Cramer's rule, and this seemed to be the simplest to actually implement in code. So let me show you how I implemented Cramer's rule to find the value of A and B. Okay, so we go in, do our normal thing, get the file. I separate by two new lines to get the first play, right? So something like this. this is what separating by 2 lines will give you. It'll just give you this part. And then once I do that, I will go through each of those strings, and then I'll call my find values. Ignore this part. Let me just, if I comment that out, because this is for part 2, and out of the 13 days, this is my first part 2. So we're gonna get into that in a bit. But where was I? So yeah, I use regex to find all of the digits in here. So what it does, it goes in order. So extracts 49, 95, 28, 16, that and that into a simple array by using regex. So I've got my digits here, right? I keep them as floats just in case, well, I'll have to check it after. And then this is the matrix multiplication that the website gave us, right? This exact matrix multiplication. So if I look at details, so you do that by that, so first thing you do is multiply this. Okay, this is not the right one, but you multiply these two, that gives you your delta D, and then this will be your delta 1, and multiply and subtract again. I didn't actually convert it into matrix as the code here says, because I don't know, it'll just confuse me more. So and the pattern is the same, right, for all of this, so I can just index it directly and then subtract it. And then again, you divide, to get A you divide delta 1 by our delta, and to get B you divide delta 2 by our delta. And this is the main thing to figure out if that equation is possible. If we actually get an integer back, the problem is solved. We have found our A and B. However, if it isn't, that just means it's a failure. We haven't actually found that. Even though it is solvable, for this scenario it would not work, right? So if that happens, we return -1 and 1. And that is basically it. So once you find your actual positions of A and B, all you have to do is create a total. For every A token you add 3, cost of 3, and for B it was 1, so I don't have to even multiply that, and I add it to the total, so the total will go through the whole file and get me all of the tokens. That is part 1 solved. And the part 2 was the same thing, but just a million more. So if I go into, zoom out a little bit, for part 2 all it says is for our actual prices we just add a million. And my idea here is that given how you wrote the code, it might be too large of a number to actually solve it efficiently. I think I had this in day 9, I think, I can't remember, but where they just gave us a larger number and my code just crashed, like it would not work. So I left it because it was not efficient enough. But in this case, it worked like a charm. So basically I went in here and for our reward, for our prizes, I just added a million. That is it. That is all I did. And my code, of course, gave the right answer. So today we solved part 1 and part 2 on day 13, when I thought I was never going to do it after looking at day 12's problem. So guys, if you feel like quitting, just keep coming back to read the question at least, right? Because sometimes you will find a gem. It might be your type of questions, and that it is. That is all I am going to say, and I will catch you all probably tomorrow, probably in a week, when I can actually solve the problem. So adios, mis amigos.